So I want to talk a little bit about objects, and I want to mention that there is a Google Slides thing on this as well, and I think there are old videos, but I wanted to make a fairly short or concise video concerning objects. A couple of things that I want to mention about this is that this is really can be a complex topic. It can there are whole big thick books on how you define objects and what kinds of things can be in an object and what kind of things cannot. So I'm going to give you just a thumbnail of that. First I'm going to show you this notepad with a few words and a few concepts, and then we'll look at a few objects and lucid charts. Alright, so here are a couple of terms. There are four parts of being an object. There's abstraction, there's encapsulation, there's inheritance, and there is polymorphism. I've only listed these two right here because these are what we're going to focus on. Although I have it down here, this is abstraction. The idea is that an object should be abstract. It should be as general as possible. Not a particular, not John Smith, not Jane, but a customer in general. This actually has deep implications when you're designing complex software because you keep trying to move things into more and more abstract classes. These two relate to encapsulation. An object should be about one thing, and everything in the object should relate to that thing. And we'll talk a bit more about that. But part of that is that it should not, like a customer shouldn't have a method in it that says add customer, because that's external to the customer class itself. The customer class itself is just about a customer. Adding a customer is something for another class to do. And an object should be self-contained. Insofar as possible, it should not rely on any other objects for its processing. The idea of objects is that they should be like Legos. You can pull one out and you can put another one in. Or like components in a computer. When you want to replace your video card, you just pull one out and plug another one in, right? You don't have to know the internal structure of these things because they're self-contained. They do what they're supposed to do. And that's how an object should behave. So here are some objects, and these are for the lock. I guess there's one other thing in that. Objects should represent the natural elements of a system under consideration. So for our lock example, we've got a user, we've got the lock itself, we've got a scan of the lock, and we've got something that validates the scan. So and there's probably other objects as well. In fact, I'm sure there are. There are classes that are just utility classes, things that like clean up or make sure that something else is happening. So not all objects represent the physical objects of the system under consideration, but that's where you start. That's where you start thinking about them. All right, so a class diagram. Some of you may have seen these before. It's just a diagram of what a class is, and they're fairly close to the code. So here's a class for user, all right? And we have the user ID, which will be an integer. We have the username, which will be a string. We have the email, which will be a string. You don't have to put the data types in here, but it can be useful to do so. Down here we have the methods, and I did this for Python. Neighbors mowing the lawn. Hopefully that won't disturb this too much. Anyway, this is the init is the constructor where you pass in some values. We've got a user ID, a get in a set, a get in a set, and a get in a set for the different things. Get lets the user see a value. Set lets somebody add a value. The string is a method that's built in that can return a string when the class is called. We'll look at that when we do coding. I don't know why the neighbor always has to start up machinery right as I'm working. So this is a lock class. Again, we got the lock ID, location ID. The minus, by the way, means private, and the plus means public. The theory is that every field should be private and and then should be only exposed with gets and sets. I did not include all the gets and sets for these, but you could. We've got the lock with the scan and then the validator. So the first assignment with classes is just to come up with the objects that relate to the kiosk, figure out what the fields are that describe them, and then what methods would belong to that object. So probably you would have objects, just to give you a hint to start, like customer for sure, employee, sale, right? And you'd probably have an item, what the item that's being sold. So that's like 3 things to start with. All right, so I think that's all I'm going to say about these. If you have questions, let me know. This part the hard part is thinking about what these objects are and what kinds of values they're doing. These are really close to code. When you have these down properly, it's pretty easy to code them. That'll be in a couple weeks, and I'll show you how to do that. So I am going to let that be it for objects. And I'm going to make a second video here on object relations. So I'm going to stop